Okay, so look at your notes from yesterday. The very bottom, you had this little true false section. And you have this diagram. Number 1, true or false? Angle AEB. So AEB would be this angle here. Angle AEB is an acute angle. It could be, right? But we don't know exactly what that is. We don't have any indication of what that is. So I would put false. Number 2, segment AE is parallel to segment BC. Do we have anything indicating that those two segments are parallel? No. So we can't assume that. That'd be false. Segment AB is perpendicular to segment BC. So AB, BC. I would say false. We don't have any information for that. AB is less than AE. It looks like it, but like I said, we don't have anything there indicating the length. So I would put false. The measure of angle ECB, which would be here, is 90 degrees. It could be, but we don't know. So false. Angle BEC and angle ECB are supplementary. So let's see where that's at. I'm going to erase my markings. So BEC, be here, and ECB, saying those two add up to 180. They could, but we really don't know. So I would put false here. Number 7, angle AEB, and BEC, are complementary. Don't know, they could be, but we don't have any indication if it is or not. So false. Number 8, C is the midpoint of BD. Sure looks like it, but you can't assume that. The only way you could assume that is if you had these two little marks right here. That means both of those segments are the same. That would mean C is the midpoint. Okay, so we don't know that, so that's false. Number 9. Angle BCE, right here, and ECD would be here, are a linear pair. Do they make a line when you put them together? Yes, that's one of the things we talked about yesterday. That's one of the things you can assume from a picture. You can assume vertical angles. You can assume linear pairs. So that would be true. Number 10, angle ABE and angle ECB are complementary. So where is that at? Let's see, ABE, do this part right here, and then EBC would be here. Do we have something that indicates that those are 90? That little box that I just drew over. That means 90 degrees. Complementary also means two angles add up to 90 degrees. So that would be true. Questions? All right, look at the mini proofs page. Number 1, we did this one together, but we'll look at it. B is between A and C. So AB plus BC equals AC. That was just your segment addition postulate. Right, number 2, B is the midpoint of AC. That's your given. And then it says number 2, segment AB is congruent to segment BC. What makes that happen? Definition of a midpoint. All right. Number 3, there's a typo here. So number 2, where it says XAB is congruent to angle ABY, that should be BAY. Fix that. And if you have a picture, we have X, A, and Y. And if you have this angle bisector, AB, angle XAB is congruent to angle BAY. So what was that one? Angle bisector. The definition of angle bisector. Next one. B lies in the interior of angle MAR. That's given. Number 2, the measure of angle MAB plus the measure of angle BAR equals the measure of angle MAR. That is kind of like number 2, no, sorry, kind of like number 1. An angle addition postulate. So you have angle addition and you have segment addition. They're very similar. How are we doing? Number 5, your given statement is the ray AB is perpendicular to, is that a ray or a line? I can't tell. Maybe it's a line at M. Okay, so angle AMC is a right angle. That's just definition of perpendicular lines. Because when you have perpendicular lines, those intersect at 90-degree angles. Number 6, angle B is congruent to angle B. Does anybody remember that one? Reflexive property. See, all these definitions we looked at Monday, you're looking at them. This is why I said you should read through those, I don't know, 10 times. Get used to it. I know, but you need them. All right, number 7, the measure of angle ABC equals the measure of angle DEF. That's your given statement. You're trying to prove the measure of angle DEF equals the measure of angle ABC. So what happens when you just switch them around? What property was that? Symmetric. Remember that one was A equals B, and then B equals A. Symmetric property. Number 8, your given statement says segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So AB equals EF. What was that? Anybody remember? Transitive property. And this one can kind of get confused with substitution, but this is transitive. Think about hopping from one to another. Number 9, your given statement says angle 1 and angle 2 form a linear pair. Okay? You're trying to prove what makes this happen. Angle 1 is supplementary to angle 2. Isn't that in the definition of the linear pair postulate? Huh? All right, next page. Number 10, your given statement, AB equals BC, and then you're trying to prove what makes this happen. AB is congruent to BC. That's just the definition of congruence. If they're equal, they're congruent. Right, number 11, your given statement. PQ bisects RS at T. Okay. And then you're trying to prove T is the midpoint of RS. What is that? Okay. Definition of segment and bisector. Number 12 is substitution property. Number 13, that's just the definition of supplementary. 14 is definition of a right angle. 15 is symmetric property. 16, definition of complementary. 17, substitution property. So look at 17. It says AM plus XY equals AW. Okay. So XY equals MW. So you're plugging in MW for XY. That's what this step is down here. And then angle 1 and angle 2 are vertical angles. That's just vertical angle theorem when they're congruent. Okay, so let me pause the video.